This is a very good collection of exercise you can be asked on t distribution, test you how you can understand the problem. Okay, so before we start solving the problem, I'd like to explain to you one more time about the t distribution. So t distribution, the table, the format of the table is very, is quite different. It's somewhat different from the z table you have already seen before. So for example, it is only the right part, the upper area that's being given. So it's to the right, as you can see, to the right. And there's very limited information given here. For example, so for each 1 degree of freedom, I'm talking about the first one, degrees of freedom equals to 1, you're gonna have 1 bell curve. And for the next one, you're gonna have a second bell curve, a different bell curve. And the second different bell curve is gonna be, let's see, the second bell curve is gonna be narrower. So I like to do a better job this time by drawing, okay. So this one is degrees of freedom is 1. Okay. When you have a bigger degrees of freedom, for example, degrees of freedom is 50, it's going to become narrower. The middle part becomes taller, as you can see, is taller, whereas the two ends become narrower. I think this is not a right drawing. Okay, pardon me. I'm going to redraw this one. This is actually not right. Okay, so I'm just going to draw the first one and the second one. Right, okay. So I like to emphasize, if your middle part, for example, this part is taller than the black curve, you have to make sure the two ends has to be shorter than that. Otherwise, you cannot make sure both curve have a total area of 100% or 1 under it. So it's very important. If the middle part is taller, the two ends have to be shorter. So this is the key, has to be lower. This is the key. Okay, if you go down this curve, okay, if you go down this table, what is the last degrees of freedom you guys have? What is the last degrees of freedom you guys have? That's infinity, right? Infinity. So anything whenever the degrees of freedom is more than 100, you're gonna use this rule. Okay, I want you guys to take a closer look of the numbers here. Do any of the numbers look familiar to you? Any of the numbers somehow, you have already seen it before? Yes, have already seen some. Yes.
1.96.
1.96, right? Okay, any other numbers you have seen before? 1.945 and 2.576. You have seen this as 2.575, which is fairly close. Where do those numbers appear? Where do they come from?
The Z table.
The Z table, absolutely right. So Z distribution, this comes from the Z distribution. What does it say? This actually implies when the degrees of freedom is really high, anything more than 100, the t table, the curves you can get from the t table, the numbers, the scores, or maybe multipliers are actually the same as a Z distribution. And the reason is because you probably have already heard me saying that in the videos. When the degrees of freedom increases, the t table or t curve becomes similar. T curves become similar to Z table. So as the degrees of freedom goes up, the T table, the T distribution becomes closer to the Z distribution, right? So when you go out there and collect more sample, your sample proportion, your sample standard deviation becomes a closer approximation to the true population standard deviation. You guys remember we were using the Z, the sigma, and the Z. And when do we use the sigma? If this one is known, you're gonna use a T. If this is if sample standard deviation is no, sorry, if the sample standard deviation is known, you're gonna use if the population standard deviation is known, you're gonna use a Z distribution. If the sample standard deviation is known, you're gonna use a Z distribution, right? Remember? Okay, so when the degrees of freedom is so big, it becomes say 200 or infinity, you can pretty much use the Z distribution to approximate it, right? Okay, so this part is important. As the degrees of freedom increases, the Z distribution becomes similar, becomes closer to the Z distribution. Okay, Another thing you want to, okay, so another thing you want to realize is the numbers here are very limited. So for each curve, say degrees of freedom equals to 35, I'm just gonna draw one curve. When I just draw one curve, it's much easier. It only gets tricky when I try to draw two curves. I have to make sure, you know, the top part and the end is gonna match up, but I'm only drawing one, so it's not a concern. When degrees of freedom is 35, you only have this 6 numbers here to represent the entire curve. Whereas for the Z table previously, we were having 2 pages of numbers to describe that curve. So what I'm trying to emphasize here is you have to do a lot of approximation. In reality, you're gonna see very rare cases, you're gonna see your numbers appear here. If you don't see them here, you're gonna use approximation. You're gonna give a range instead of an exact number, right? Okay, so you're gonna use that concept to solve our problems as well.